Welcome to the Cow Corporation's series of videos about software engineering. The topic of this video is compile time constants. Before proceeding, make sure that you have already watched these other videos first. C++ has different kind of constants, runtime constants and compile time constants. When you mark some variable as a runtime constant, it's still just a variable, just like any other variable that you have. The only thing you've done is to tell the compiler that you don't plan to be assigning any value to it other than its initialized value, and that you want the compiler to stop you from accidentally doing so. That's different from a compile time constant, which is an expression that the compiler can evaluate at compile time. The importance of some expression being a compile time constant is that the compiler would be able to make use of that value while it's doing its compiling work. In C++ syntax, there are some places where the compiler needs to know an expression's value at compile time, and thus they must be a compile time constant expression. One example is the numeric value which underlies each enumeration value. It's not restricted to being only a numeral. It could be a full expression like 1 plus 2, but that expression must be a compile time constant. For some compilers, the size of an array is another thing that must be a compile time constant. Function calling is an action that happens at runtime. Thus, an expression like this 1 plus 2 cannot contain any function calls, not if it's going to be used in places like these, which require a compile time constant. Furthermore, these expressions cannot even instantiate temporary objects because an object constructor is also a function. We could have just used a macro, but our getTo function is so simple. It's a pity that we couldn't have used its function syntax instead. Of course, the enumeration can't actually call the function because calling is a runtime action. But what if the compiler could analyze getTo at compile time, determine that its result would have been 2, and then do something kind of like macro substitution, where that value of 2 gets used for defining this enumeration. Starting in C++11, we actually can do this, but only for some really simple functions. Even though getTo is a very simple function, it is still a function, and thus we should still be able to also call it at runtime, just like any other function. But this doesn't work with most functions because there are so many complicated C++ language features that would make it too hard for the compiler to analyze it in this way. Instead, only some really simple stripped-down functions are allowed. Specifically, in order for a function to be used for a compile time constant, it may not return void. All of its parameter types must be primitives. Any variable declared within this stripped-down function must have local lifetime. Furthermore, all variable types must be primitives, and all variables must be initialized. On older compilers, the function could only have one return statement, which needed to return a constant primitive expression. If a function meets all of those limitations, and you might want to use it in a compile time version of a call for a compile time constant, then you mark that function's definition with the keyword constexpr. one of these stripped down bare bones functions can call other such stripped down functions. Recursion is permitted also. For many variables, evaluating their value is an action that happens at runtime, and so a compile time constant cannot contain such a variable in that expression. But there are some exceptions. For one, if a variable is a constant integer and it is initialized, and its initialization value is a compile time constant, then that variable also qualifies as a compile time constant, and it could be used in these compile time constant expressions. If a variable would have qualified for the previous exception, except for the fact that it's floating point instead of an integer, then that variable needs to be marked by constexpr if you want to use it in a compile time constant expression. The variable could also be a constant object of a custom type, but then that class may not have any custom destructor, and you need to mark the variable by constexpr, and all of the constructors, copy constructors, and operator overloads all need to be stripped down and marked constexpr themselves.